Oh, okay. We're getting started with our afternoon session. So we're going to start out with a base roll-ups panel that will be moderated by Justin. And we have Joe from Aztec. So why don't you guys come up and take your seats. Brecht from Taiko and Marek from Celo.
Testing.
Okay, let's get started. We have a pretty amazing panel that was organized with three great panelists here that are representing L2s or soon to be L2s, as I understand. I guess, shall we do a very quick round of introductions, starting with Joe?
Hey everyone, my name is Joe. I'm one of the co-founders of Aztec. For those of you who don't know, we're building a privacy-first L2 on Ethereum. And we hope to, like our friends Taiko, launch fully decentralized. And yeah, kind of base sequencing and the protocol side of things is dear to our hearts because we want to launch a roll-up that's going to be around for many years. So I'm looking forward to this panel, and thanks for having us.
Hey everyone, my name is Marek. I'm one of the co-founders of Celo. It's so nice to see you all. It's amazing that you all made it through immigration. Really, really amazing. So Celo, if you're familiar with it, or if you're not familiar with it, it's an EVM-compatible L1, really focused on kind of ease of use and payments. And it's currently transitioning into an L2. And so I think I have a maybe slightly more unique perspective from the other panelists here, coming from that L1 to L2 world. And on that front, just today, we're super excited to announce that we launched the Dango testnet, which is basically our first step towards this L2 migration. So Dango is a testnet. It's OP stack based. It's a full L2 with all of the Celo features, all of the really great things around fee abstraction, social connect, ultra green money, all of the things that make Celo special. It's all kind of baked in. And folks can now start playing with it. So yeah, I'm really excited to be here.
Hey everyone, I'm Brecht. So I'm from Taiko, and Taiko is trying to be like a Ethereum equivalent like ZK Rollup. We're also based like a month ago or something. We kind of like launched on mainnet, and we are actually based, but we're not actually a ZK Rollup yet because we still have to enable ZK Rollups, ZK proofs. But we'll have in like in a month or so. But yeah, based Rollup. So cool stuff.
So, quick show of hands here. Who's bullish on base rollups? Ooh, interesting. So I'd say more than half the audience, which is very, very surprising. Like generally speaking, I think it's been a journey where like your initial reaction to base sequencing is that it's maybe too good to be true, or it doesn't work for X, Y, Z reasons. Like, do you align with that story that like base sequencing has grown on you over time?
Yeah, I think it's been a roller coaster. It's gone up and down. I think for us, like we've always had based properties, and kind of like one thing that being based gives you is falling back to Ethereum's liveness properties. And so whatever you do to try and build ahead or build faster than Ethereum, I think it's very important to have like an emergency mode, which falls back to being based and kind of allowing anyone on Ethereum to just propose a block. And if you do that, your system will be pretty resilient to everything that comes with it. Yeah, I think that's kind of always been like a constant truth in being based. We then try to like overload it and maybe use it to get faster pre-confirmations, and that's where the roller coasters come in on how well it does that, but we can save that for a future question maybe.
But does Aztec need pre-confirmations?
We have a bit of a tricky time because the amount of data needed to process the Aztec state transition function, which is a ZK proof, is very large. Like every one of our transactions is a ZK proof. And so these proofs can be 32 to 100 kilobytes. And so if you compare that to an optimistic rollup where the data's just a signature, like 32 bytes, it's much harder to kind of make sure that data's available. And so if we didn't have a form of pre-confirmation, we'd have to fall back to just having a block every 10 minutes, which would be a pretty poor UX. So I think maybe the diehards in the room would say that's fine for a fully decentralized privacy system. A block every 10 minutes is much better than we have kind of for anything else out there, because nothing really exists. But I think for usable applications, you do need some form of pre-confirmation if you want to get mainstream adoption. So yes, I think we do need pre-confirmations.
And Joe, would it be fair to say that maybe one of Aztec's main motivation for base sequencing is the strong censorship resistance, and specifically because you're touching like a sensitive topic, and you could potentially be compelled, or like actors in some sort of external sequencer could be compelled to censor maybe?
Yeah, 100%. I think falling back to Ethereum's, what is it, 1 million validator set or proposer set is the best kind of censorship properties that we have at the moment, and hopefully that gets better with inclusion lists and other things in the roadmap. But yeah, I think falling back to that is one of the main reasons for sure.
And Marek, you're transitioning from an L1 to an L2. You probably don't have the same kind of censorship resistance considerations. So for you, potentially moving to based sequencing, is it fair to say that it's mostly for composability reasons?
Yeah, I think that's right. So I think Celo transitioning from an L1 to an L2 is mostly around kind of alignment with the Ethereum roadmap. We started off in the Ethereum ecosystem. We wanted to build a really easy-to-use kind of global Venmo-like wallet that people could use for payments globally on Ethereum, and we realized that we couldn't make it work on Ethereum in 2017, and so that took us down the path of launching our own L1. But since then, obviously, the Ethereum scaling roadmap has come out, and it no longer really made sense for us to be in the Ethereum ecosystem, not as a roll-up. And so I think first and foremost, that's the main reason why we're transitioning. And as part of that decision, suddenly composing with both the L1 and other L2s, it becomes really, really exciting for us. It's true that when it comes to censorship resistance and one-block finality, given that we're already focused on payments, we've spent a lot of time thinking about this and creating a validator set that gets slashed if 2/3 of validators equivocate. And so on the censorship resistant front, for short time periods before you get settlement on the L1, I feel like we have a lot of good experience there. But when it comes to composability, I mean, that's what gets me really excited, right? The prospect of doing full L1 composability is just, incredible. And so, yeah, absolutely.
And Brecht, I'm trying to understand the motivations from the Taiko's perspective, right? Because you are a pioneer, like you're literally the first rollup that has a decentralized sequencer, and you're learning as you go in some sense, and there's a lot of reinventing the wheel and rebuilding infrastructure, and you arguably not yet getting all the benefits of composability and whatnot. And so, what is the main motivation for you other than just sheer conviction?
I guess in the beginning it was just like simplicity. The simplicity aspect was like a big thing, where we just did not have to come up with like our own kind of like way to select the sequencer. And I think that's kind of like one of the big things. So we did want to focus on like being as decentralized as possible, but then the extra benefit of like the simplicity. And you could say like at this point we kind of like get more of the downsides than some of the upsides actually from like base sequencing, because we do not take advantage of like shared sequencing because there's only like one base rollup now, which is Taiko, and we do not take advantage yet of like synchronous composability or like any composability with like L1 yet. So I guess we are kind of like building towards something that we want to have. We're kind of like not there yet at all to kind of like, yeah, to take advantage of these things that base sequencing enables.
Very interesting. So 3 different reasons for moving into base rollup: central resistance, composability, and simplicity. Let's see. What are, like, for those that are not yet based, like, what would be one of the improvements or pieces of infrastructure that you'd like to see? We have the whole roadmap around pre-confirmations, and lots of builders are building that. Recently, there's been a bunch of people who have been interested in reducing Ethereum slot times, including Vitalik, to make the Ethereum sequencer more attractive. Are these things what you want to see happen before you make a final decision, or are there other things that you'd like to see?
Yeah, I can go first. I think it's working. I think the biggest one is just more DA throughput. So we could be a full-based rollup today. We would put all of this witness data we need to construct a proof in blobs. And I think we would use 4 to 5 blobs every Ethereum block. The blob base fee would go like this, and we'd be able to do 0.1 transactions a second. So it wouldn't be very good for the other rollups on the panel. And so I think a roadmap to get to kind of full dank sharding a lot quicker would mean that we have to build a lot less to leverage Ethereum's shared sequencing infrastructure. So I think, yeah, clear timelines to getting 12 blobs, 64 blobs, and then full dank sharding would be the biggest win. Then the other stuff is a nice to have, I think, that gives us more functionality when we get there.
Yeah, so this is a really, like, interesting and subtle technical consideration that, in order to do the proving, Aztec has all this witness data, and there's tons of witness data. And the simplest would just be to put it on chain, but there's just not enough blobs. And so if we did have a lot more blob space, then base sequencing for Aztec specifically would be much simpler. Marek, is there anything, like, specifically you'd like to see built out?
Yeah, certainly. I mean, on the composability front, I think there's still obviously a lot of work still being done. I think there's how many people here are familiar with kind of atomic inclusion, atomic execution, and then full composability? Yeah, I see 3 hands up. So maybe just to summarize, so once you have a shared sequencer, you can start doing atomic inclusion of transactions across chains or across L2s and L1. That's compelling, but you aren't guaranteed that these transactions will execute. And so the next step is to collaborate with block builders through PBS to then guarantee execution of both of these transactions. That's how you get atomic inclusion, execution. And then finally, this holy grail of being able to call transactions or call functions across chains is kind of full composability. And on that front, I think there's just a lot of work still to be done. And I think one thing that I'm particularly excited about seeing is just work on what the spec for doing that will end up looking like for L2s to compose with the L1. I think there's been some efforts from certain projects, and I don't know if they're kind of Ethereum sanctioned yet. So I'm kind of curious what the direction of that will be. On the censorship resistance front, I think certainly lower block times absolutely is very interesting. And I think that could motivate us down the road to moving away from other, I guess, decentralized sequencer options.
Understood. And Brecht, I know that you're, like, actively working towards pre-confirmations. That's one of your next major milestones. I know there's been a lot of pushback from certain people within the community, worried about, for example, missed lots and reorgs kind of jeopardizing the robustness of pre-confirmations, or maybe pre-confirmations adding centralization pressure to block building. Like, what do you have to say to these critiques?
The centralization aspect I don't fully understand, because Ethereum as it is now is already, like, very centralized, and I don't see, like, how pre-confirmation can make it, like, even worse, or, like, well, it can make it, like, a little bit worse, but not like that much worse. So I'm kind of, like, interested in what your opinion about this, because I don't fully understand the argument, like the centralization argument.
I mean, I agree with you that it's hard to make it worse because it's already pretty bad. But I actually think it becomes significantly better. And the reason is that right now, block building is monolithic. So the most competitive builder gets to build the whole block. Whereas with pre-confirmations, it's a real-time, shred-by-shred kind of auction. And in some sense, you remove the builder. There is no more builder. There is the proposer and the users. And then they use searchers to build, to solve intents for the users. And because you have this kind of real-time block building, you don't have this notion of one dominant bully builder that can, for example, censor over the whole block. And so in some sense, I think pre-confirmations just remove the builder from their position of power and solves the problem in some sense, the builder centralization problem.
So that's a good thing. That's,
good news.
Good news. And yeah, for like the reorgs, I think I recently checked there's roughly 5 reorgs per day. Is that I'm not sure if that's kind of like the
I think there's a few more than that.
Is it more?
But basically, my take on the reorgs is that the reason why we see reorgs today is that the L1 proposer makes one of 2 mistakes. Mistake number 1 is that they don't build on the correct parent. Or mistake number 2 is that they don't broadcast the L1 block on time. Now, if they were to not make these mistakes, then they can basically guarantee on the synchrony, meaning under normal network conditions that Ethereum has had since Genesis, that they won't get reorged. And so if I am an L1 proposer that is giving out pre-confirmations, I need to make sure that I have a good enough setup, a good enough internet connection that I'm going to build on the correct parent and broadcast on time. And so I think what we're going to see is that pre-confirmations are going to be extremely robust because if you miss your slot, you're going to get penalized, and it's fully within your control as to whether or not you get reorged.
Okay. So, well, I guess then no real dependency on single slot finality. Although the plans there might also change what it actually means now. But yeah, there's ways to get around it.
Yeah, single slot finality really is a defense against 51% attacks, which also we haven't seen. But yeah, I agree that if we were to have a 51% attack, then you could attack the pre-confirmations since the last finalized checkpoint and the tip. But to a very large extent, single slot finality is orthogonal to pre-confirmations. Really, pre-confirmations is deeply tied to the short-term fork choice rule.
When you're saying pre-confirmations, are you just talking about inclusion pre-confirmations or execution?
Execution.
Okay, yeah.
But some users might be fine with just inclusion, but in terms of capability, I mean execution.
Yeah, I think that it gets a bit more tricky in the execution pre-confirmations because we've been running some rough modeling on this because we have the same issue on Aztec, and you can cause someone to act on this potential future world state, and if let's say an easy example would be in this future world state, the Uniswap pool has now got 0 USDC in it. So people may try and put in transactions to react on that. And you can quite quickly get into a world where the kind of effect of an attack on the potential execution state that the pre-confirmation is securing, or the bond is securing, is much higher than the size of the slashing penalty. And so we haven't yet convinced ourselves that the cost of lying about a future state of the world when it's going through one centralized actor is worth it compared to the risk. So that's something we want to see more research on.
Right. I mean, one thing you can look at is what is the incentive for a proposer to renege on all their pre-confirmations. And one way to look at it is the maximum amount of MEV that we've seen in a single slot, right? Because imagine that there's, for example, some huge market event that changes all the prices on the exchanges, and now I have an incentive to renege my pre-confirmation so that I can pick up all this arbitrage. Well, the maximum block since the merge is, I think, 792 ETH. So if you have, let's say, 1,000 ETH of collateral, you can cover even the worst case since the merge. But one of the nice things that you can do is that you don't have to come in upfront with 1,000 ETH of collateral. You can instead have just-in-time collateral, where you have a transaction that comes in, and they basically dictate how much collateral they want to pay for. So it can become a more market-based, just-in-time kind of thing. That's interesting, yeah.
Do you not need to have, take into account other domains though? Because the price, let's say you do this attack where you convince the world that in the pre-confirmation chain, the Uniswap ETH dipole has gone to 0 and die. Doesn't that affect centralized exchanges and other venues who are kind of feeding into that price? So do you not need to look at kind of other domains to also work out what that bond is securing?
I mean, you can only provide pre-confirmations for a specific transaction. So you'd need to have within your control a transaction that brings the price to 0. Like someone would be willing to just burn like tens of millions of dollars. And if they were willing to do that, that's fantastic for you as a pre-confer. Like now you can just arbitrage it for free.
That's fair, yeah.
I mean, there's been quite a bit of pushback on base sequencing. There's been a lot of drama and critiques. Like, is there like one piece of pushback that you disagree with, that frustrates you, that you'd like to voice, or some specific insight, underappreciated thing about base sequencing that you think the market
Yeah, I can take that one. So I think, this vision of Ethereum transitioning to be a place for data availability, for sequencing, and for validation of state changes on L2s. I mean, that to me is an exciting kind of vision for Ethereum. And so I think and it just makes sense that you have all of the 3 things that you need to build a rollup to be offered as a service from Ethereum. So I think from a pure kind of vision and roadmap perspective, it just makes so much sense for Ethereum to go in this direction. And I think from that perspective, I'm very, very excited about it. I think figuring out the exact technical details to make this compelling for L2s today, I think I have a lot of certainty that over time we'll figure it out.
So you find the meme very wholesome, basically, like the united chains of Ethereum all coming together and aligning with Ethereum.
Yeah, and also, just as an ETH holder, I think it just gets me excited about the future of Ethereum for sure.
Nice.
Yeah, for me, I think the most underappreciated thing, or thing I disagree with the most, is that it's like an overcomplication. I think you said it earlier around simplicity. It's like, from a pure sequencing standpoint, it's one of the simplest designs, and it's the easiest to rationalize about when you're thinking about who can produce a block on a chain. If you adopt some other kind of sequencing mechanism, like Aztec's considering using RANDAO as like a way to elect a proposer and have our own validator set. You have to then think about all these different RANDAO biasability concerns and when the RANDAO value is picked. So I think, yeah, I'd push back on some of the critiques that say it's like a research exercise, because I think, and it's like an overcomplicated solution. I think it's actually quite simple and elegant for just sequencing. Maybe some of the pre-confirmation stuff is still needing to be worked out, but actual base sequencing on its own, I think, is very simple and easy to rationalize about.
And if you don't need pre-confirmations, then it is a very good match. And I think the best example here might be ENS. Right? ENS announced that they want to build an L2. They want maximum credible neutrality. They can't be building on top of Arbitrum or Optimism or Base, because that would be picking a specific ecosystem and not being neutral. And they don't care if registering an ENS takes 100 milliseconds or 12 seconds. And so for them, I think it's a very easy choice to become a base rollup.
Yeah, for ENS, 12 seconds is a lot better than a normal DNS propagation on Web 2, which can take days.
Right.
And maybe one, aspect is kind of like, yeah, the collaboration aspect, like what we've seen now and like the last couple of months. It's kind of like, yeah, all these people coming together to kind of like try to build this thing. And like also like lots of like new research and kind of like all the brain power of like Ethereum being used to kind of like solve this issue. Although like it is simple, but it turned out to not actually be that simple. Still like lots of things to like think about and kind of like take into account. So I think that's kind of like, yeah, one of the biggest benefit, I think, as well. Instead of like trying to do your own thing, kind of like try to work towards kind of like, yeah, this shared infrastructure that all the L2s can use and kind of like makes Ethereum better.
I think we have time to open it up a little bit to audience questions. Any questions you'd like to ask the panelists?
Challenge Annika, isn't it? Go for a run. So quick question about centralization and what the use case is for based rollups. Do you think that the primary user is going to just be L2s, or do you see other sophisticated actors using rollups for, I don't know, weirdo pre-confirmation stuff, or do you actually see wallets using based rollups directly on L1?
Anyone want to take it, or?
There's a question like, who are the users for based sequencing?
Yeah, who consumes based sequencing?
Yeah, I mean, I think if it's the user of a based rollup. So, yeah, I think wallets may select that if they're directing their users to a particular L2. But it's just whoever's using a based L2.
Yeah, in some sense, the wallets have no say here. Like, they'll just pick whatever sequencer the chain and the user have agreed to use. Like. And in that sense, it simplifies pre-confirmations, right? Because if as a wallet I want to give pre-confirmations as a service to my users, there's only one place in which I need to send the user flow to, and so the wallets have basically a binary decision: either you support pre-confirmations or you don't. But if you do, then there's only one way to design it. We have another question here.
Hello. Kind of following up on who the users would be of based rollups, do you guys see L3s being built on top of based rollups, or is that just like a solid no? Just curious if that's like, and if there would be any benefits for building an L3 on a based rollup as opposed to like an L2 as well.
Yeah, I think that's really interesting. So I think the criticism of L3s is that you can't compress data twice. So why create an L3 when you can just create an L2? One reason could be because you want to use base sequencing but have short pre-confirmation or short block times, I should say. So that could be actually a good reason. I think it's definitely interesting to think about, yeah.
I don't think there's like many reasons to do L3s because you can do everything as an L2 as well. So I'm more like a horizontal scaling believer than more like a vertical way. Because yeah, if you're like a based L2, then yeah, sure, it kind of like looks very similar as building directly on L1. But why not on L1 directly in that case as well?
I think it's definitely a possibility. It's like it just depends where we land in the trade-off space. If we kind of get much shorter Ethereum block times, we can enable a lot more applications at the kind of like the based L2 level, potentially. But if there's always going to be some applications that maybe need more high frequency trading, or they don't need to pay Ethereum for kind of like roll-up DA. So maybe there's a case for like alt DA as an L3. Like if you're doing a micropayment system, do you really need all those payments that are less than $1 to be secured by Ethereum? Maybe you're okay having like a hot wallet for micropayment tips, and that would be a really good example of like an L3 that could kind of roll up into a based roll-up.
We have another question there. Organizers, do stop me when I'm out of time.
Okay. It's for Joe. It's Junger from Taiko. What's your concerns about being based? Because I know you have some concerns, right?
Yeah, I think I shared them earlier. It's just it's about data, and so I think if in an ideal world, we could post all the data to Ethereum. We would be a based rollup. But if like the roadmap to getting there is still very unclear for us, so we may have to build things in the interim that make it easier for that data to be available, so people have a guarantee that an Aztec block can be built. And yeah, I think that's our number one concern, is kind of the practicality of Aztec actually being able to get high throughput, low latency blocks and be based with the current throughput limitations of Ethereum's DA.
Thanks.
And one final question.
A quick one for Marek. You mentioned quick block times. How quick block times you would want to see to the point where you don't even need pre-confirmations?
Yeah, I think that's a great question. I think it really depends on the use case, right? So in Celo's case, where I mentioned before, we're really focused on payments. There's Opera, the browser company, has a product called MiniPay on Celo that has now 3 million users, and they're just using it as a kind of a global Venmo-like product. And in that world, certainly on the order of 1 second feels sufficient. So that if you're sitting next to someone, you press send, and you can see the notification pop up relatively quickly on their phone, so you both feel good that the payment went through. Obviously, if you're not next to each other, you can have something on the order of 5 seconds plus. But I think generally people, if you look at, if you talk to credit cards and the kinds of latencies that they need to also start moving payments onto crypto rails, they talk about being able to do things sub 2 seconds, which again points to kind of this 1 second time period. If you're doing a game, if you're doing something else, then certainly the UX requirements are very, very different. But for payments, I would say about a second.
Okay, we're out of time. Thank you so much to the great panelists. Thank you.